Hello, everybody, and welcome back to Business Statistics Online at Frederick Community College. In this video, I will discuss exponential probability distributions, and I will show you how to use Excel to compute exponential probabilities. The first thing we're going to do is briefly go through some of the conceptual parts of this section. So what do we have here? We have this function, f of x is equal to lambda times e to the power negative lambda x, and that is the exponential probability density function. So this is what we use to model exponential random variables. Let's go through all of the components of this function. We have e, which is the base of the natural log. It's a number that's already built into Excel and calculators for easy computations. We have lambda, the mean number of occurrences over the interval, and that number will vary for different problems. And then x is any continuous number of interest. Now, let's take a look at different shapes that our distribution can take. So here you have examples of various lambdas and means that are associated with it. Okay, so the shape of the exponential distribution depends entirely on this value of lambda. It is right skewed. Unlike the normal distribution, it is not symmetrical. Okay, it is completely described by one parameter lambda, and the values for an exponential random variable cannot be negative. Okay, so that's something to keep in mind. And let's take a look at the probability formula. So the formula for the exponential cumulative distribution function is 1 minus e to the power negative a lambda, and that represents the probability that your value of x is less than or equal to a, which means we're looking for what? Let me go back to the previous slide. So we will be looking at the areas under the curve on the left of your function, okay? Just like with normal distribution, we compute areas up to a number, okay? And everything to the left of that number, that's going to be your probability, okay? So once again, E is that fixed number, lambda is the mean number of occurrences over the interval, and A is any number of interest. So this is a good formula to know. However, it is already built into your computations with Excel. Okay. The last thing I want to discuss before we go into solving a problem is that the mean and the standard deviation of this distribution are actually the same, and it's 1 over lambda. So that's nice. That's easy to keep in mind, and there's nothing to compute. Once you know what your lambda is, you know the mean and the standard deviation. So let's go ahead and take a look at a problem from your homework. This is going to be section 6.3, problem 6, and you might have slightly different numbers, but the problem setup should be the same. And I'm going to solve this problem entirely using Excel. Okay, so I got my Excel file open, and let's see what we have. Assume the average time between students walking up to the instructor's desk during an exam to ask a question is 9 minutes, and it follows exponential probability distribution. So what is our random variable? Our random variable is time. Okay, I'm just making sure that everything is clear as far as what is it that we're dealing with. Okay, x is time. Okay, and typically exponential functions model time. Okay, of course this is a continuous random variable, right? Okay, so I'm making all these notes just so we have everything connected. Okay, what do we have? Let's take a look. Is 9 minutes. Assume the average time between students walking up to the instructor's desk is 9 minutes. What does that mean? Okay, so our lambda is 1 student per 9 minutes. okay? It's important to determine this parameter correctly, okay? So that's done. And that's it. That's really all you need to do to start solving this problem. You know what you're modeling? You're modeling the probability that it takes so many minutes for the next student to come in, right? And what is your lambda? Okay, it's 1 over the mean. So it's 1 over 9 in this case. Okay, so let's go ahead and answer all of these questions. The probability that the next student will ask a question within the next 2 minutes. Okay, so let me bring this up here. What does this mean? This is computing the probability that x is less than or equal to 2. Okay, so first let's deal with the notation. Less than or equal to 2. Within 2 minutes, that could be in the next 30 seconds, 45 seconds, a minute and a half, and so forth. So we need to compute this probability of a student coming to the desk anywhere between 0 and 2 minutes, right? So this is an exponential distribution, okay? And Excel is very helpful when you plug in a function that's already built in. It's going to tell you the syntax. So it says, what is your x? Up to what value would you like to compute this probability? Okay, up to 2. And what is your lambda? 1 over 9. And then the next question is, would you like this to be a cumulative distribution? And the answer is yes for us. The inequality, we have this inequality, x is less than or equal to 2. Okay, so the answer is yes. You can type in true or just type in 1. Okay, so that's our probability, 0.1993. Okay, so we're going to type this in, 0.1993. Let's check. Looks good. Okay, good to go. Okay, let's take a look at the next part. This one says, what is the probability that the next student will ask a question within the next 4 minutes? Okay, similarly, x is less than or equal to 4. Computation will be very similar. The only thing that's going to be different is the value of x. Exponential distribution. My x is now 4. Okay. Lambda is still the same, 1 over 9. Cumulative, yes. Now, of course, this probability will be higher, right? Because we're moving to the right. So the tail, okay, gets to the right side. So you should have more area under the curve. And we get this value right here, 0.3588. Let's check if this is correct. 0.3588. Okay, so far so good. Let's take a look at the next one. What is the probability that the next student will ask a question between 3 and 5 minutes? Okay, so how do we do this one? This one might be a little bit tricky at first. Okay, so between 3 and 5 minutes, what does that mean? This is the probability that our x is between values 3 and 5, right? Okay, so let's type in the notation first. And then let's think about what does it actually mean. Okay, between 3 and 5. So the minimum number of minutes that it takes for a student to walk in here for this scenario would be 3. And the maximum is 5. Okay, now remember, our function computes probabilities from 0 up to that value. Okay, so what we need to do here is the following. We need to compute the probability that x is less than or equal to 5, and then subtract the probability that x is less than or equal to 3. Okay, in this case, we're getting rid of the probability that x is between 0 and up to 3, right? Okay, so how do we do this? We just have 2 steps. So first we do exponential distribution, and x here is 5. Lambda is 1 over 9. Cumulative, yes. And then just like that, subtract the other exponential part. Okay, so exponential distribution, lambda is 3. I'm sorry, x is 3. Lambda is still the same, 1 over 9. Cumulative, yes. Okay, so what this is doing, it's getting rid of the probability that x is between 0 and 2. Okay, so we get this value 0.1428. Okay, let's check this. 0.1428. We're good. So far, we're computing all of these probabilities correctly. Always a good sign. What is the last question? The probability that the next student will ask a question in more than 10 minutes. Okay, so let's go back to our Excel spreadsheet. More than 2 minutes, notation-wise, this would be x is greater than 10. Okay, so our function, the built-in function in Excel, can compute probabilities up to a value of interest, but not after, right? So it does not compute probabilities on the right tail. So what do we do here? We would be using the complement rule. So this is saying, okay, let's do 1 minus probability that x is less than or equal to 10. Okay, the complement rule says we can do this. Okay, if you want to find the probability of some event that it's difficult to compute, but you know how to compute the complement of that event, then go ahead and subtract that from 1. Okay, so this would be 1 minus exponential distribution. Okay, value of x in this case is 10. Lambda is 1 over 9, cumulative, yes. Okay, so we get this value 0.3292. 3292. Let's go ahead and plug this in. 0.3292. Final check, and we are done. Okay, so this is how you would compute your probabilities for exponential distribution function. Okay, the main points to take away from this section is a computational aspect, okay, that we still use Excel for all computations. And then also, let me go back to the slide. Okay, so computing sigma and mu, it is just 1 over lambda. Some of the questions will just ask you, what is the standard deviation for this distribution? It is exactly the same as the mean. Okay, thank you for watching.